Okay, so this is the periodic table that we are going to talk about in this periodic table. As you can see, there are vertical columns. Yes, these are basically vertical columns, which are actually called what? These are basically called groups. These vertical columns, which are actually called groups. Then we have what? We have these horizontal rows. Yes, these are what? These are basically period. These are what? These are period. Here, when we are talking about overall, here, when you see on this left hand side, from this left to right, as you go, what will happen? Metals here, most reactive metals to non-metals, means elements, their characteristics changing from metals to non-metal. I'm going to give you proper notes on it, but here we have the overview. So we will talk about group 1, which are the most reactive metal, then group 2, then here we have group 3, 4, 5, 6, 7, 8, right? And this middle block is what? These are basically transition elements. We will also talk about it. These are transition metals or transition elements. So here we have metals, most reactive metals, and here we will have non-metals. So now, we will go on the screen to talk more about it in detail. Okay, so yeah, we are already familiar with about our groups and periods. Now let's talk about group 1 metals. Okay, group 1 metals. Group 1 metals, which are actually called what? They are called the alkali metals. What are they called? The alkali metals. And why are they called the alkali metals? Because when they react with water, they form alkali and hydrogen gas. Yes, and hydrogen gas. Keeping in mind that group 1 metals, as we go down the group, what happens? Reactivity increases. Okay, here, we are talking about, we are going down the group. What is happening? Reactivity increases. Reactivity increases. So when we are talking about group 1 metals, we already know lithium, sodium, potassium, right? So lithium, sodium, potassium, rubidium, right? This is how we are going down. Cesium, francium. Okay, so what will happen as we are going down? Reactivity increases, means this is the least reactive in this group, and this is the most reactive, as we are going down in the group. Okay, now what is the definition, what is the equation for these reactions when they are reacting with water. So let's write the equation. When I'm talking about word equation, let's change the color. Word equation is what? Let's take metal. Metal is going to react with water, and it is going to give you alkali. Okay, and it will give you hydrogen gas. So when I am doing this, which metal? The first one, lithium, I'm going to take lithium. It is reacting with water. Which alkali it is going to make? It is going to make lithium hydroxide, right? Hydroxide, because alkali and hydrogen gas and hydrogen. Now, what will be the equation of it? Yes, that is also very interesting. Okay, so how we are going to write the equation of it when we say metal reacting with this? Let's write the equation. When they say equation is lithium Li, water H2O, lithium hydroxide LiOH, plus hydrogen H2. Make sure our equation is balanced. Here we have 3H and the other side we have 2. So we need to make it 4. right? And 2 goes with this to balance lithium as well. So this is going to be our equation for this. So I want you guys to try writing equation with sodium and potassium at least. Okay, so since we have written these chemical equations for group 1, now we will be talking more about their physical properties. Okay, let's talk about their physical properties as well. Physical properties. So when we are talking about their physical properties, let's talk about their melting and boiling points, density, and all those, right? Let me draw this. Okay, first, let me write all of them here at a side. That would be easier when we have lithium, we have sodium, we have potassium, we have rubidium, cesium, and francium, right? We are there. Now, what we are doing here, let me draw it. Let me change the color. As we already know, reactivity increases down the group, right? Other than that, what we will have, we will be talking about their physical properties. What are those physical properties? Their softness. Softness increases down the group. Also keeping in mind their appearance, the color, that they will have, what it will be silvery light, silvery white, and as we are going down further, it will get darker, means silvery gray, then silvery gold. Okay, yeah, so it is gonna go like this. So like if I'm talking about sodium, it is gonna be silvery white, right? Sodium also silvery white, I'm using SW. Potassium also silvery white. Rubidium silvery gray, SG silvery. Then this one gonna be silvery gold. And keeping in mind, francium is basically very rare. It is very rare. It is what? It is radioactive element. And just for knowledge, you should know, since you are learning in detail about group 1. Then go to the other section. What there we will talk about density. Density increases down the group. Density also increases down the group. Yeah, so we are going to remember that. Okay, they are lighter. Okay, generally they have lower density than other elements of the periodic table. So what we can say generally, because sometimes in the exam they would ask you, okay, like in the difference between group 1 and transition elements, physical properties difference. So there you can mention that they are lighter. Generally they have lower density as compared to other metals. But when we are talking about particularly in the group itself, so down, as we are going down, density increases. Also now, talk about melting and boiling point. Yeah, this is the different point. Sorry. Melting and boiling point, when I'm talking about melting and boiling point decreases down the group. Melting and boiling point decreases as we are going down the group. Also keeping in mind, generally they have much lower, okay, generally when we are talking about much lower boiling and melting point, I write BP boiling point and MPU melting point, much lower boiling and melting point as compared to other metals. Okay, yeah, so this is about group 1. Now we will move to our other groups. Okay, so here, since we have already spoken about group 1, group 2 metals also show quite similar trend. As group 1 metals, group 2 metals are also reactive metals, but they are less reactive than group 1 metals. Yes, they are more reactive than other metals like transition metals, group 3 and so on, right? But they are less reactive than group 1 metals. So group 2 metals also, they are called alkaline earth metals. Okay, their reactions are also similar. Okay, so we will go further, means after group 1 and group 2, let's move to our transition block. Transition block that I showed you already. Let me take you back to the periodic table so you understand better. Yeah. So here, now transition metals that I'm talking about, we are going to talk about this middle block. Yes, these are basically transition metals when, we are talking about. So group 1 and 2 that we have covered. Now we are going to talk about this middle block. We will be talking about these group, this group of transition metals. Yes, here, let's talk about the transition element. As you know, we know that they are in the middle block, the transition element, okay, or we call them the transition metals, basically. So what are they? Let's talk about their physical and chemical properties, okay? As you know, I was telling you when we were doing group 1 that whenever in the exam you have to compare it with transition metals. What you are going to talk about in physical properties, we can talk about that they have higher densities, a higher density. When we are talking about higher densities, what when we are talking about higher densities in terms of as compared to other metals, okay, as compared to other metals. So they have, I think so, let's write it properly. They have higher density, okay. Then other than that, they also have higher, use the word higher instead of high because it's the comparison. They have higher melting points. Other than that, we can talk about what they are harder. Okay, harder. Again, because we are giving the comparison, they are stronger. Okay, then, next property that, we are talking about forming color compounds that can actually fall under physical property as well as chemical properties. I'm going to put here because since, it gives you the physical change as well, right? Chemical properties when we are talking about, do not say they are color metals, right? They form colored compounds. We can give, some of the examples here when we are talking about, we have many of them. Okay, what are they? For example, when I'm talking about here, for example, iron, right? Iron 2, Fe2 plus. What will it form? It will actually form green compounds. Iron 3, Fe3 plus. What will it form? Red brown, right? So like this, okay, we have copper, which actually forms blue. We have cobalt, which is pink, right? And so on. Okay, so these are some of them that we are going to remember. Okay, so they form color compound. You may write this under physical property as well. Other than that, they are used as catalysts. Yes, this is very good point. They're used as catalysts. What are they? What does it mean? Even though they are expensive metals, right? We know that all these platinum, right? Gold, they are falling in it under this section. But catalyst, okay, what is a catalyst? We already know it is a chemical substance that, this is additional, you don't need to explain in transition metals. A chemical substance that speeds up a chemical reaction, and most important part, what? And remain unused. Yes, because it does not take part in the reaction and remains unused, unchanged. So it means when it remains unused, it can be used again and again, right? So yeah, they are used as catalysts, means they can be used over and over again, which actually makes them economical, right? Okay, other than that, let's talk about they form or shows more than, or you can say multiple, they form multiple oxidation states. Okay, what does it mean? Multiple means more than one. What are they? Here, like here, I have given you the example of iron 2, iron 3, right? So we can talk about it, iron 2, iron 3. Even you know that we have the example of copper here. So copper also we have copper 1, copper 2, right? So this is what their oxidation states, their valencies that, you know, they show. Okay, right? Yeah, so this is about transition elements. Okay, so now, you know, we will be talking about our non-metals. Non-metal section, the most reactive non-metals are here in group 7. Like, you know, we had our most reactive metals, that was group 1 right here. So similarly, here we have this section, which is group 7. These are basically non-metals. So we are going to talk about it now. Okay, so when you know we are talking about our group 7 elements, they are basically, what are they called? They are called the halogens. Group 7 elements, they are called the halogens. The halogens, basically they form halides, halide salts. So when you know we are talking about them, let's, you know, put their element first. What do we have in it? So we have fluorine at the top, we have chlorine, we have bromine, we have iodine, and we have acetylene. Keeping in mind that unlike group 1, when we are going down the group here, what will happen? Their reactivity decreases. Yeah, keeping in mind, here, you know what we are going to talk about. We will write the equations as well. Okay, when we are talking about this, their reactivity decreases. This is our main point here. In group 1, we had reactivity which was increasing. In group 7, reactivity decreases. Let's talk about it further. We will be writing the equations as well about it. How about their physical properties? Let's talk about it too. So when, you know, I'm talking about the physical properties of these halogens, physical properties, that will be better for you. So in the exam, you know, as they ask you, you will have all the points to score marks. Yes, now it's all perfect. So now here, when I'm talking about their color, as you know, we are going down the group. Do you know what happens when we are talking about color? Color gets darker. Color gets darker. Okay. When I say color gets darker, what does it mean? Like, you know, we have fluorine. So fluorine is what? It is yellow in color. Fluorine, which is yellow in color, right? Then chlorine, which is green. Then, you know, bromine, which is dark red or red brown liquid. Okay, then we have black iodine and acetylene, which is very rare. This is also a radioactive element. Okay, yeah. So we are going to remember that, you know, their color gets darker. Also, you know, keeping in mind their state, you know, state of matter at room temperature. What is it gonna be? What is it gonna be? It is gonna be fluorine, which is a gas. I just want to give you guys all, so I'm just putting up here gas. Okay, bromine, which is liquid. Okay, as we are talking about, and black solid. Okay, and this is radioactive, which is very rare. Now, you know, as we will go ahead, let's talk about other property. Okay, how about their boiling point? So, my dear students, remember boiling points. As you know, we are going down for them. What happens? Boiling point increase. Boiling point increase. Boiling points increase. Okay, yeah, so these are their physical properties that we are going to remember. We already know that fluorine is what? Fluorine is a gas, right? Chlorine is what? Chlorine is a gas too. Then bromine, which is a liquid. You need to remember, their states of matter. Iodine, which is actually solid. This is what we are talking about. We are talking about all this at room temperature. Yeah, all these details, we need to take to understand it better. Okay, now we will go further in halogens. Okay, we will talk about their chemical reactions. Let's go to the next slide where we are going to talk about their chemical reactions. Also keeping in mind, they are all poisonous nonmetals. They are toxic. Okay, yeah, this is important point before, we go for chemical equations that we are writing. We are talking about the halogens, right? Okay, what I am saying that they are poisonous. Non-metal poisonous, or we use the word toxic. These are toxic non-metals. Also keeping in mind that they exist as diatomic molecules. They exist as diatomic molecules. Di means two, right? So when I'm saying diatomic molecules, there are two of them, two atoms in each molecule, two atoms in each molecule we are talking about. Okay, so what does it mean when I say diatomic? Means I'm going to talk about F2, right? Cl2, Br2, they will all be existing as diatomic. Let me write it here so you understand it better. I am talking about F2, Cl2, Br2, I2, okay, astatine, At2, At2, right? Yeah. So they will exist as diatomic molecules. Now, come to their reactivity. Okay, when, we are talking about reactivity, we already know that as we go down the group, it decreases, right? Reactivity of halogens. Also, keeping in mind that more reactive halogen displaces, sorry, type over. More reactive halogen displaces less reactive halogen, but it cannot be the other way around. Means less reactive is not gonna displace more reactive. Yeah, so this is the important point. When we are writing the equations, we are going to remember. Okay, what does it mean? Because I already have their reactivity, right? I already know that as we are going down the group, why we are writing all this again and again, so we remember. We have fluorine, we have chlorine, we have bromine, we have iodine, we have astatine, right? So we already know when we are going down the group, reactivity decreases, right? This is halogens. Group 1, their reactivity increases as we go down the group. Halogens reactivity decreases as we go down the group. So it means that fluorine is more reactive than chlorine, bromine, iodine, astatine, right? So now, let's, understand what do I say when I say more reactive halogen can displace less reactive, what does it mean? Okay, now here let's talk about their chemical reaction. Okay, what is the chemical reaction? Let's write the equation, word equation first. Potassium bromide reacts with chlorine. So when potassium bromide, it is reacting with chlorine, we know that chlorine is more reactive than bromine. It means it can displace it from the compound. So potassium chloride plus bromine will be formed. And why it is going to be formed? Because chlorine being more reactive, it has already displaced bromine from its compound, taking its place, right? What will be the equation of it? Potassium bromide, we already know the formula, KBr, right? Potassium bromide, chlorine, as I already mentioned that we want in diatomic form, so Cl2, right? What will be the formula of potassium chloride? KCl. Bromine, Br2, right? Halogens in diatomic form. Now let's see whether the equation is balanced or not. And so need to balance 2 here, and all set to go, right? Now, I would want you to try more equations. So here, what are we going to continue? Sodium iodide and bromine. So yes, it is gonna give us what? It is gonna give us sodium bromide plus iodine, because we already know that iodine will be displaced by bromine. Why? Because bromine is more reactive than iodine, so it can displace it from its compound. Now, come to the other example where, they have given us lithium chloride with bromine. Since, we already know that bromine, bromine is less reactive than chlorine, right? So what we have already learned that only more reactive can displace. So since, bromine is less reactive, so means it is not going to displace it. So what we are going to write, no reaction, right? So this is how, we're going to do this one also. Let's write, their formula equation, sodium iodide, NaI plus bromine. It's always good to, practice equations. It will help you build confidence in chemistry. NaBr, and here we will have iodine. So you are going to put 2 here, and the equation seems balanced, right? Yeah, so this is about halogens. Yes, so now, we have already talked about halogens, group 7. Now we are finally moving to our group 8. This group 8, which are actually noble gases. Yes, so this is our group 0. We are going to talk about it now.